27 inverse trig ratios. We're going to do mostly what we did in the last video. However, we're going to find a missing angle using right triangle trig, the inverse, instead of using regular right triangle trig to find sides. So diving further in, we talked about last class where we are using an acute angle and the side lengths, the opposite, the adjacent, and the hypotenuse. We can form 6 distinct ratios between the sides. Those ratios were sine, cosine, and tangent. What we were doing is we were using an angle reference point, or sometimes an angle measurement, and the trig ratios to come up with the ratio, which was our answer. What we're going to do now is using these ratios to find an unknown side. What we're going to do now is we're going to find an unknown angle, and the way we're going to do that is we're going to use a ratio or input a ratio and use the inverse trig to come up with an angle measure as our answer. So going through them one by one. The sine function we had talked about is the ratio of the opposite side to the hypotenuse. Well, I put in an angle and I get out a ratio. Well, inverse sine, if I put in a ratio, the opposite over the hypotenuse, I would be able to come up with the acute angle theta. Cosine is the same idea. For the cosine of theta, we put in an angle or used a reference angle, and we were able to find the ratio of the adjacent to the hypotenuse. For inverse trig, we could go ahead and put in the ratio adjacent over hypotenuse and come up with an angle. Lastly, we were able to do the tangent of theta, which was we put in an angle and we came out with the ratio of the opposite to the adjacent. I should say adjacent. And with inverse trig, we were able to put in the opposite over the adjacent, and we're able to come up with an angle theta. As an example, here is a triangle where I give you all the angle measures and all the sides, so there's nothing really to find. We're just going to verify what we're seeing. So if I ask you for the sine of 36.9, here is 36.9, the angle measure, and I'm going to go ahead and label my side. Starting with the hypotenuse, which is the largest side, opposite the right angle. Next, the adjacent side is the other side length that forms the angle in question, and then leaves out the opposite being our last one. So if I asked you what the sine of 36.9 is, the sine is the ratio of the opposite to the hypotenuse, and substituting in our known values gives us 30 over 50, or the ratio 3 over 5. As a decimal, 0.6. Now, if we try to work backwards here and I ask you for the inverse sine of 30 over 50, inverse sine is a button on our calculator. It is located directly above the sine button on our calculator. So we're going to hit second sine to give us inverse sine. And then we can put the ratio 30 over 50 into our calculator, and we should be able to get an answer, which will be an angle. Doing so, we get the angle measure 36.9. Hey, that's what we expected it to be. Using the ratio 30 over 50, or 3 over 5, we expect to get the angle measure of 36.9, which we already given in our triangle. Okay, let's now look at a few examples. Top of practice page 2, we're going to look at example 2, where we're using trig ratios to solve for x. In each of these cases, you should note that I have a question mark there. We're going to replace that with an x, and we're going to put a theta an angle measure next to it, just to remind ourselves that this value is inside the triangle, so I should be looking for an angle measure. And I've done that on all 3 examples. So focusing in on the first example, we want to go ahead and find for x. Now, there's 2 ways to go about doing this problem. And the first way is to approach it just like we've been approaching every problem up to this point, which is using our reference angle. We're going to go ahead and label our sides: hypotenuse, adjacent, and opposite. And looking at what we are given the opposite and the hypotenuse side, which means we're going to use the sine function. Now, substituting in our known values, we are left with, gives us sine of x degrees is equal to 28 over 35. Now, the question is, how do I get the x by itself on one side of the equation? Well, we have to get rid of this sine. Well, the question is, how do I get rid of a sine? Well, if I gave you x squared equals 4, and if I gave you x plus 3 equals 10, the way we would isolate the x's, we would do the inverse operation. So to get rid of x squared, we would take the square root of both sides. If I wanted to undo x plus 3, we would subtract 3 from both sides. So in similar fashion, we need to do the inverse operation of sine in order to both sides of the equation to isolate x. So what is the inverse of sine? Well, it's inverse of sine. So I'm going to take the inverse of sine of both sides of the equation. What that looks like all written together is inverse sine of x degrees is equal to inverse sine of 28 over 35. Well, just like on our if statement, when I took the square root and squared, they undid each other. And here when I subtract 3 from adding 3, they undo each other. What's going to happen here is the sine and the inverse sine will undo each other, and we are left with x degrees is equal to inverse sine of 28 over 35. This we can type into our calculator, giving us an answer of 53.13 degrees. Okay, so in recap, we started off like we always do, looking at our angle of reference, labeling our sides, figuring out which trig function we have, and then substituting in our relevant information. From there, we're stuck with a new problem in the sense of, how do I get rid of this sign? Well, I take the inverse sine of both sides of the equation, just like we would take the square root of both sides in order to do squaring. We would subtract 3 from both sides in order to undo addition of 3. Those undo each other, and we're left with something we can type into our calculator and get our answer. Now, I said that there were two ways to doing these problems. This first one, again, is starting off exactly like we had done before. However, I would like to draw attention to the fact of this statement right before our answer. X degrees is equal to inverse sine of 28 over 35. This is some angle measure theta equal to the inverse sine of some ratio. We have seen this before. Well, on the notes, if I wanted to find some angle theta, we could just put in inverse sine of the opposite over the hypotenuse. So if we are savvy problem solvers and we come up to our triangle, we still label like we had done before, hypotenuse, adjacent, and opposite, looking at our angle of reference. But if we notice that we're looking for an angle theta, or in this case angle x, we can start off by just using that formula, or substituting in our known value, which gives us the same answer of x is equal to 53.13 degrees. So if we're savvy about what we're trying to actually find, and we notice we're trying to find an angle theta, we can jump directly to the formula that I gave you, or we can approach it exactly like we had done before by taking the inverse sine. Either way is fine.